So hello everyone, this is Sumit and today we are going to learn about the probing. So probe refers to the searching for the next empty box. Sometimes two values wanted to go in the same place but we cannot put in one box. So we start looking for another empty boxes nearby to keep the value. So what it says, look here. We have inserted a 22 element at 0th index, but at the same index we have inserted the 12 value at the 0th index, but the 22 value also wanted to go at the 0th index, but we cannot put as it's the limit or it's a slot says it's filled only one element at a one slot or one index. So what it says, probing says, we start looking for the another empty box nearby. So what's the nearby index? It's a 1. So it will start inserting the element at the 1 index. So it's nearby index called 1. So we'll insert the 22 element at the nearby index, which is called 1. So that's the probing says. So to searching for an empty box called the probing. Probing means to search the empty box nearby filled elements. That's called the probing. And basically we have three type of probing technique. Number 1, linear probing. Number 2, quadratic probing. Number 3, hashing probing. So in short, we'll see here what's linear probing. So take a day-to-day life example. If we are entered a class after class starts, so your friends get seated on the benches starting from first, second, third bench. So the vacant bench is 3 and you start looking from the first bench, second bench, and we goes to the third bench. This is called the linear probing. We starting at the first bench, second bench, third up to the empty bench and we settle down that position. That's called the linear probing. And second one is a quadratic probing. So we'll see with the same example. So let's suppose we have reached at the first bench which is filled, then we move on second bench because one square is 1. So quadratic probing means what's the looking number, take the square of that number. So 1 square is 1, so we start looking at the second bench which is 2. So if the second bench will be filled, so take the square of that number. Second bench means 2 square which is 4. So we skip between the numbers or between the benches. We start looking at the fourth bench directly, skipping in between numbers. That's called the quadratic probing. And third one is a double hash probing, which uses two hash function and which having a formula of h of k equal to k mod 11. So it will overcomes the disadvantage of quadratic probing. So disadvantages of quadratic probing means it skips the benches in between square numbers, so it may be vacant or it may be filled. So sometimes quadratic probing goes on a loop. So overcome to this quadratic probing, we invented the double hash probing. So let's see the properties of good hashing function. So first one is a fast to calculate. For every search or delete operation, it would be simple and arithmetic. So for searching or deletion, which is easy and simple. So first one is a fast to calculate and second one is a uniform distribution. Hash table distribute a key evenly across all the slot of the table instead of putting too many in one slot. So we'll see at the array example. So we have 4 index of array. So what we does, we fill the element one by one, not we insert at 0th index all elements, it may leads to the collision. So uniform means we evenly distribute at first index. So if filled, then move on second index, third index up to the index full, means it's a 4 index array. So we'll fill 0th, first, second, third and the array will get full. That's called the uniform distribution if uniformly distributed. And as the example says, if table size is 10, so filled at 0th index, first, second, third up to 10th index. So that's called the uniform distribution. Then we'll see the bad hash function. What is the bad hash function? In simple words, I would say a function which taken daily day-to-day life example. If we are putting, take a freeze example, we are putting all vegetables in a one container. This may leads to the confusion. Tomatoes, chilies, we get mixed. Instead of we that's the same example consider here. So take h of k equals to 1. So all keys are 21, 31, 41, 51 and 61 goes to the slot 1 and it leads to the heavy collision. This is uniform. So what it says, all keys were present here will go at the 0th index. So all will get at the 0th index, that's the says, and we'll see with an example. So the formula for calculating the bad hash function, h of k equals to 1. So key values are 21, 31, 41, 51 and 61. So 21 mod 10 which is equals to 1, which gives the remainder as a 1. So 21 get inserted at 0th index. So we'll insert the 21 at 0th index. After that 31 mod 10 which also gives the index 1 value. So we'll insert 31 in first index. After that 41 mod 10 which also gives the remainder 1, which is called, it will also get inserted at the first index, and 51 mod 10 which also gives the remainder 1. So as we have to insert the 51 as in index 1, as 61 also gives remainder 1. So all in elements were inserted at the 1th index. This may leads to the collision. That's called the bad hash function. After that we'll see the better hash function. What is better hash function? So for calculating better hash function, key mod m is a formula, and where m is a table size. So each keys go to the different slots spread across the table. This is uniform distribution. As we above sees, the uniform distribution means we have inserted the elements across the array size and not repeated in single element in same slot. So that's the same case of better hash function. We'll see with an example. So here keys values are 21, 31, 41 and 51, where m is a table size, as we draw on the table, which is called as array 0, 1, 2, 3, 4, 5, 6, 7. These are 7. Table size is 7. So we'll insert the element as its table size. As the table size is given 7, so always array starts from the 0th index. So we'll create a table size of 7 index. So what it says, hash function is equals to the key mod m. Key means the value is given, keys values, and mod, and m is a table size. So 7 is a table size across we all. So h of 21 equals to 21 mod 7, which gives the remainder 0. So we have to insert the 21 at the 0th index. So we'll insert 21. So we have inserted the 21 at the 0th index. So after that we'll see 31 mod 7, which gives the remainder 3. So what is means? It means insert 31 at the 3 index. So we'll insert the 31 at 3rd index. So we have inserted the 31 at 3rd index. After that 41 mod 7, which gives the remainder as 6. So we have to insert 41 at the 6th index. So we'll insert the 41 at 6th index. So we have inserted the 41 at 6th index. After that 51 mod 7, which gives the index 2, means it gives the remainder 2. So we have to insert 51 at 2nd index. So we have inserted the 51 at 2nd index. So this is called the better hash function. See the difference between bad hash function. It all elements get inserted at one index, at the same index, which is 1. So collision will happen here, and see below. Here all elements when evenly distributed, not even a single element collide with each other, where all elements are get inserted at the slot size is 1, so all at one index one element goes, so here collision will not occur. So after that we'll see the deterministic. A hash function is a deterministic if the same key produces same index. We'll see with an easy example. So let's suppose two students having the same roll number. That's the simply says a hash function creates same key and same indexes. So example, h of k equals to k mod 10 if key equals to 21 mod 10, which gives the one index. If again inserted or searched 21, it will always give the first index. So if we won't change 5 7 randomly because the function is fixed, here function is fixed. So we'll see with an example. If student Amit has a roll number 21, he can always be found at the position 21 in the register or records, but this roll number kept changing daily, so finding him would be impossible. So if we have to find the student called Amit which assign the roll number 21 which is fixed, so I have no his roll number, as we can find him 21 which is Amit, so we'll find the student easily by classroom or college as divisions. So this would leads to the easy access of that student, as same case applied to the data elements which is stored in the storage values which is called arrays or linked lists. So thank you guys for the listening.